We grow up believing reality is solid, that the world exists independently of us, that objects have properties, and that space and time are stable containers where everything happens. This belief feels natural. It feels obvious. And that may be the problem. Because the deeper physics goes, the less confident it becomes that reality exists in the way we experience it, not distorted, not incomplete, but fundamentally different. For centuries, science reinforced our intuition. Planets followed predictable paths. Objects obeyed clear laws. Causes led to effects. Reality behaved like a machine. You could take it apart, study each piece, and understand the whole. This worked extremely well. Until physics looked too closely. At the smallest scales of existence, reality begins to misbehave. Particles stop acting like objects. Location becomes uncertain. Cause and effect blur. And the most unsettling part is not what quantum physics reveals, it's what it refuses to confirm. In classical physics, an object has properties, whether or not anyone observes it. A rock has a position, a planet has a trajectory, a clock ticks forward. Observation changes nothing. Quantum physics breaks this assumption. At the quantum level, particles do not behave like tiny objects moving through space. They behave like probabilities, not metaphorically, literally. Before measurement, a quantum particle does not have a definite position. It does not have a single state. It exists in superposition, a combination of all possible states at once. This is not ignorance. It is not that we don't know where the particle is. According to the theory, the particle is not anywhere specific. Only when we measure it does something strange happen. The wave of possibilities collapses. One outcome becomes real. All others vanish. Reality, it seems, is undecided until observed. This is not a fringe idea. It is the foundation of modern physics. Quantum mechanics predicts experimental results with extreme precision. Every modern technology, from semiconductors to lasers, depends on it. And yet, its implications remain deeply uncomfortable. Because if particles do not have properties until measured, what does that say about the world when no one is looking? For a long time, physicists hoped this was just a limitation of our knowledge, that hidden variables existed, that reality was still definite underneath. We just couldn't see it yet. But decades of experiments have closed that door. Reality does not appear to be hiding fixed answers behind the scenes. It behaves as if those answers do not exist until interaction occurs. This leads to a disturbing question. Is observation creating reality? Or is reality something that only exists in relation to observation? The problem deepens when we consider entanglement. Two particles interact briefly, then separate by vast distances. According to quantum mechanics, they remain connected not metaphorically, not through signals, but through shared state. Measure one particle here, and the other responds instantly, even across galaxies. There is no time delay, no exchange of information. Einstein called this spooky action at a distance. He disliked it, not because it was strange, but because it threatened the idea of an objective reality. If particles don't have independent states, if their properties depend on context, then reality may not be composed of separate things at all. It may be relational, a network of interactions, a process. This challenges something deeper than physics. It challenges the idea that reality exists by itself. We usually think of the universe as a stage. Space and time form the background. Matter moves across it. Events happen within it. Quantum physics suggests the stage may not exist independently. Space and time themselves may emerge from deeper relationships, not containers, but consequences. Some interpretations take this even further. They suggest that the universe does not have a single objective history. Instead, reality branches. Every quantum event creates multiple outcomes, multiple worlds, multiple versions of existence, all equally real. In this view, nothing ever truly collapses. Reality simply splits, and consciousness experiences only one branch. Others reject this and propose something equally unsettling, that consciousness plays a role. Not mystical, not supernatural, but fundamental. Observation is not passive, it is participatory. This does not mean the mind creates the universe in a human sense. It means that measurement, interaction, and information are central. Reality may not be made of matter. It may be made of relations. At this point, physics begins to resemble philosophy, and philosophy begins to feel uncomfortably close to physics. Consider this carefully. If the universe does not have definite properties until interaction, then what was reality like before observers existed? For billions of years, there were no eyes, no brains, no measurements. And yet, stars formed, galaxies evolved, atoms assembled. So what was observing the universe then? One possibility is that interaction itself is enough. Particles observe particles, systems observe systems. Measurement does not require consciousness, only interaction. But this still leaves a problem. Interaction requires distinction, something interacting with something else. But quantum mechanics resists clear boundaries. Systems do not have sharp edges. Everything is entangled, directly or indirectly, with everything else. This leads to a radical idea. Reality may not be built from objects. Objects may be built from reality. What we perceive as solid, separate things may be emergent patterns, temporary stabilities, in a deeper, fluid process. This would explain something else, why reality feels stable at our scale and deeply unstable at smaller ones. We evolved in a world where quantum effects average out, where probabilities collapse into certainties, where the impossible becomes invisible. But that does not mean it disappears. Quantum physics reveals a universe that is not fixed, not fully determined, not entirely real until engaged. This raises a final, uncomfortable question. What does this mean for us? We usually think of ourselves as observers inside the universe, separate, looking outward. But if observation is fundamental, then we are not outside reality. We are part of the process that gives it form. Not in a powerful way, not in a meaningful way, but in a subtle, unavoidable way. Our measurements matter. Our interactions matter. Not because we are special, but because nothing is special. Everything participates. This dissolves the boundary between subject and object, between observer and observed, between mind and world. Reality is no longer something out there. It is something that happens. This does not make the universe friendly or purposeful or aware. It makes it stranger. Because a reality that is not fully real until interaction is a reality that does not care about certainty. It does not promise meaning. It does not guarantee truth. It does not offer comfort. It simply exists partially, probabilistically, conditionally. And perhaps that is what reality has been hiding all along. Not a secret structure, not a final answer, but an absence of solidity, an absence of certainty, an absence of a single, objective world. We look for reality as a thing. Quantum physics suggests it may be a process, and processes do not wait to be discovered. They happen, with or without us. The question is no longer, what is reality made of? But something far more unsettling. Why does reality allow itself to appear at all?